In this video, we're going to continue our discussion with the language of hypothesis testing. All right, so for the scenario below, determine the null and alternative hypotheses and explain what it would mean to make a type 1 and type 2 error. So historically, the time to order and deliver a pizza at Jimbo's Pizza was 48 minutes. Jim, the owner, implements a new system for ordering and delivering pizzas that he believes will reduce the time required to get the pizza to his customers. All right, so let's write out the null and the alternative hypotheses. So the null would be the mean is equal to 48 minutes. And the alternative would say that it's less than 48 minutes. All right, so type 1 error. Well, with type 1 error, you would reject the null hypothesis when the null hypothesis is true. So what would this mean in this case? Jim concludes the delivery of pizzas will be less than 48 minutes, but in fact it takes exactly 48 minutes. Now, with type 2 error, what exactly happens here? You don't reject the null hypothesis when the null hypothesis is false. So, what does that mean here? Jim concludes the delivery pizzas will be exactly 48 minutes, but when in fact it takes less than 48 minutes. So that's a type 1 and type 2 error in this particular case. So let's take a look at another example. So in 2008, 62% of adult Americans regularly volunteered their time for charity work. A researcher believes the percentage is different today. So we've already done this prior to, so again, I'll write out the null and alternative hypotheses. Okay, so stop the video and write out what you think the type 1 and type 2 error would be for this problem. Okay, so type 1 error would be as follows. The researcher concludes the proportion who regularly volunteers is not 6200s, when in fact the proportion is 6200s. Type 2 error, the researcher concludes that the proportion of adults who regularly volunteers is 6200s, when in fact the proportion is not 6200s. We never know whether the conclusion of a hypothesis test is correct. However, we can determine the probability of making errors when testing hypotheses. The following notation is commonplace. So alpha is the same as the probability of type 1 error, and that means the probability of rejecting the null hypothesis when the null hypothesis is true. Beta is the probability of type 2 error, and this is the probability of not rejecting the null hypothesis when the alternative hypothesis is true. The level of significance alpha is the probability of making a type 1 error. The choice of the level of significance depends on the consequences of making a type 1 error. If the consequences are severe, the level of significance should be small. Let's say alpha's 1/100th. However, if the consequences are not severe, a higher level of significance can be chosen, such as maybe 5/100 or 10/100. We might ask, why not always have alpha equal to 1/100? Reducing the probability of making type 1 error increases the probability of making type 2 error, and vice versa. As one goes up, the other one comes down. All right, so once the decision whether or not to reject the null hypothesis is made, the researcher must state his or her conclusion. Remember, we never accept the null hypothesis because without having access to the entire population, we don't know the exact value of the parameters stated in the null hypothesis. Rather, we say that we do not reject the null hypothesis. All right, let's take a look at an example for this. So according to a study published in March 2006, the mean length of a phone call on a cell cellular telephone was 3 and 2500 minutes. A researcher believes the mean length of a call has increased since then. Suppose the sample evidence indicates the null hypothesis should be rejected. State the wording of the conclusion. Now, before we do that, I'm going to write out the null and alternative hypotheses for this now. So the null hypothesis is population mean is equal to 3 and 2500 minutes. The alternative hypotheses would say the population mean is greater than 3 and 2500 minutes. All right, so the null hypothesis should be rejected. Here's what you should write for this. There is, or there seems to be, sufficient evidence to suggest the mean length of a phone call on a cell phone is greater than 3 and 2500 minutes. Part B. Suppose the sample evidence indicates the null hypothesis should not be rejected. State the wording of the conclusion here. Well, I'm going to write that now. There is not sufficient evidence to suggest that the mean length of a phone call on a cell phone is greater than 3 and 2500 minutes. We'll always write this with respect to the alternative hypotheses because that's what they're trying to investigate. Okay, let's take a look at the next example. So historically, the time to order and deliver a pizza at Jimbo's Pizza was 48 minutes. Jim, the owner, implements a new system for ordering and delivering pizzas that he believes will reduce the time required to get a pizza to his customers. So again, before we do A and B, let me write the null and alternative hypotheses for this problem out again. Now, see if you can write the conclusion based on the null hypothesis should not be rejected and should be rejected. Stop the video now, write it out, and then start the video up again when you are done. All right, so for part A, there is not sufficient evidence to conclude the delivery time for pizzas is less than 48 minutes. State the conclusion based on the null hypothesis should be rejected. There seems to be sufficient evidence to conclude the delivery time for pizzas is less than 48 minutes.